presentation explains how I chose a problem statement, how I used the design thinking process, and how the solution can support societal growth during flood emergencies. The main scenario I selected is the flood rescue. During floods, many people get trapped inside houses, on rooftops, or in low-lying areas. The worst part is that mobile networks and power lines often fail exactly when people need the help the most. So the problem is not only flooding. The real problem is communication failure during flooding. Imagine the situation. It's the middle of the night, a residential area is flooded, a family is trapped inside their house, but there is no signal. They may try calling emergency numbers, but the call does not connect. Rescue teams are also searching, but they do not know the exact location of every trapped person. This is not a random imaginary event. We have seen flood situations like Chennai, Kerala, where communication becomes a huge challenge. When the network goes down, even smartphone becomes almost useless for emergency communication. That gap inspired this problem statement. The core insight of FloodTrace, my solution, is that nearby people do not need to do anything. They just need to exist nearby with Bluetooth on. The app does the rest silently. To design the solution, I followed the design thinking process. First, I identified the problem. Second, I tried to understand the users through empathy. Third, I defined the exact solution direction. Fourth, I created a simple prototype idea. Fifth, I tested the miscommunication concept. Finally, I looked at the possible impact. This process helped me avoid jumping directly into a fancy idea. Instead, I focused on whether the problem is real, whether users actually need the solution, and whether the solution can be built using existing technology. Choosing the problem. While choosing the problem, I considered three major factors: scale, existing gap, and feasibility. Scale means the problem should affect many people, not just a small group. Flood affect many families, rescue teams, local governments, hospitals, and volunteers. Existing gap means the current solution is not enough. During floods, normal mobile networks may fail, maps may become outdated, and rescue team may not get the real-time information. Feasibility. Feasibility means the solution should be practical. I do not want a solution that sounds good only on paper. I wanted something that can work using smartphones, local communication, and a simple dashboard. Next, empathy for users. I looked at the users. The first user group is the victims. Their experience is panic, fear, and confusion. Their pain point is that they cannot communicate their location when the network fails. The second user group is the rescue teams. They may be brave and ready to help, but they do not often know the location. So they are forced to do a blind search. Their pain point is the lack of real-time data. They may not know which house help need the first. The third user group is the official and coordinators. They may depend on outdated maps, manual updates, or even phone calls. Their pain point is coordinating rescue operations without clear live information. This empathy stage made the problem more clearer. The solution should not just be a rescue app, it should help victims send their live locations, help rescuers find priority areas, and help officials coordinate better. Defining the solution. After understanding the users, I converted the problem statement into a design question. How might we help the flood victims communicate their real-time location without depending on mobile networks? This question became the base of FloodTrace. The idea is to allow a trapped person to send an offline SOS signal from their phone. Nearby phones can just pass the signal to another device, like a chain. When any phone in the chain reaches internet access, the SOS data get uploaded to the rescue dashboard. So the goal is simple. Even if the trapped person has no network, their emergency message can still travel through devices. Rejecting ideas. Before finalizing these ideas, I have also rejected some solutions. For example, depending only on siren is not enough because siren cannot share exact location. Satellite phones are powerful but expensive and not practical for common people. Drone-based rescue operations is useful but cannot be the only solution because drone needs operators, battery and weather clearance. So I focused on more scalable idea. Use smartphone because people already have it. The idea is simple. A trapped person taps an SOS on their phone. The signal is broadcast via Bluetooth. Any nearby phone that has Bluetooth switched on with the app installed can receive the signal. Even if the owner is sleeping, unaware, or not pressing any button, it automatically picks up and forwards the signal. No action is needed from the relay person, just Bluetooth on. Prototyping. The prototyping of the flood dress has three main parts. First is the offline SOS button on the victim's phone. The user can one tap to send location and emergency status. Second is the mesh relay system. Nearby phone act as a temporary signal carriers. They do not actually need to know the victim personally. They only help forward the SOS message. Third is the rescue dashboard. Once the SOS reaches the internet connected device, it appears on a dashboard as live marker. Rescue teams can then see where help is needed. The prototype is intentionally simple. It does not try to replace government systems. It supports them by giving faster location data during network failure. Each phone acts as a temporary silent relay point automatically in the background. The person holding that phone does not need to open an app, press anything, or even know they are helping. Their phone just need to keep Bluetooth enabled, which most people keep on by default. Testing the mesh. To test the concept, I imagined a campus. First, we turn off all mobile data to stimulate network failure. Then, one phone sends an SOS signal. The signal hops to nearby phones through short distance communication. Each phone becomes a relay point. Finally, one phone gets the internet access. The data is uploaded to the rescue dashboard. This shows that small number of connected devices can create a communication path. This system becomes stronger when more people install and use it. Final product and impact. The core feature of FloodTrace are offline SOS, mesh relay, and live dashboard. Offline SOS help victims send emergency information even without mobile network. Mesh relay help the messages travel through nearby devices, and the live dashboard help rescue teams and officials see trapped people and map and prioritize rescue operations. The biggest advantage is that the solution uses existing technology. People do not need to buy a separate device. In disaster situations, even a 10% adaptation rate in the locality can create a useful rescue mesh. The societal impact is also important. The faster location sharing can reduce rescue delay. Rescue teams can work with better information. Citizens can indirectly help each other just by keeping app installed. To conclude, FloodTrace is a design thinking based solution for real societal problem. I started the problem of flood communication failure, understood the users, defined a clear challenge, rejected impractical ideas, created a simple prototype, and tested the concept through a mesh network model. The key learning is that innovation does not always mean inventing a completely new technology. Sometimes innovation means using existing technology in a smarter way for societal good. Thank you.